Hello students, in this session we will discuss about the power performance of the vehicles, which is one of the dynamic characteristics of the vehicle. Okay, let us first understand what is the requirement of power performance of the vehicle. A knowledge of the power performance of the vehicle is very much essential to determine the running cost of the vehicle, and also it is used to design some of the geometric elements like grades. Apart from that, the power developed by the engine, that is denoted by the letter P, suffix P, the power developed by the engine, that should be sufficient to overcome certain resistance to the motion, which is essential to maintain the design speed and to accelerate your vehicles at the any desired speed. So what are all those resistance that which will cause reduction in the speed of the vehicle. So some of the resistance that includes rolling resistance, air resistance. Rolling resistance is denoted by P suffix F. Air resistance, which is denoted by P suffix A. Grade resistance, P suffix I. Inertia forces due to acceleration and deceleration, and as well as the transmission losses. We will discuss in detail how these resistance will affect the movement of the vehicle. Okay, the first one is the rolling resistance. We'll understand how the resistance to the motion occurred. Okay, so as the name indicates, rolling is nothing but there is a resistance to the motion of the wheels. So why this occurs? Okay, road surface will have irregularities and the road surface will offer certain roughness, okay, which will cause deformation of the tires. Whenever the vehicles move on such undulations, irregularities or the roughness, the certain impact will be caused on the tire, okay, that will hinders the rolling motion of the vehicle. Okay, so you can see here the road surface as undulation. Because of this, a force will be developed, a resistance. The force is nothing but a resistance will develop, so that will hinders the movement, rolling action of your wheel. So this you call it as the rolling resistance. So whatever that rolling resistance that is developed, that will depend upon the what is the roughness of the pavement as well as what is the total weight of the vehicle. So hence we can calculate rolling resistance as MFG, where M is nothing but your mass of the vehicles in kg, F is the coefficient of rolling resistance, and G is the acceleration due to gravity. So here F, the coefficient of friction resistance, so that either you can determine, or we have a IRC recommendations for various type of surface, okay, so which is used in the construction of the road. So here we'll look into that what are all the code values. What does the code value? So the IRC will recommend the value of certain values up to a speed of 50 kilometer kmph, kilometer per hour. Okay, so the code value what is given, we'll see that in the next slide. So that table value will be given up to a speed of 50 kilometer per hour. Whenever the speed is increased higher than the 15 kmph, you need to apply the correction factor as given in this formula below. So where here F naught is the what the code value which says up to a speed of 50 kmph. Whenever the speed of the vehicle exceeds more than 50 kmph, apply the correction factor and use the new value of coefficient of friction that is developed. You can see here in this table what are the value of coefficient of friction for various type of surfacing. So if you have the pavement surfaces of cement, concrete or asphalt surfacing, so the rolling resistance nothing but the F value is in between 0.01 to 0.02. Similarly, for other type of road surface, the coefficient value is given here. So you can see here. So once the smoothness is for lower category of the road, the resistance developed will be more. So this stable value what is given by IRC is up to a speed of 50 kilometer per hour. So whenever the speed is increased, apply the correction factor based using the formula which I have given you in the previous slide. So the next one is the air resistance. So when the vehicle is in motion, so air resists the movement of the vehicle in various way. What are all the causes for this air resistance? So first cause is the air itself will have certain density. So whenever vehicles move at a high speed, so from the opposite direction, the air will hit on the front surface of your vehicle. So that will cause the resistance to the motion. That's the first reason. Second reason, so the friction, the friction between your air and the sides of the vehicle. So that offers certain resistance to the movement of the vehicle. And also the effect of eddying of your air behind the vehicles, under the body of the vehicles, that also causes resistance to the motion. And also whenever you open your window, the air flow through the vehicles for ventilating, so that also causes certain resistance to the movement of the vehicle. So now how to determine the value of how much the air resistance that is caused. So that can be determined using the formula PA is equal to CA into AV square. So where PA is the air resistance which is measured in terms of Newton. A is the front projected area of the vehicles in the meter square. Okay, so what is the projected area? The front portion, what is the height of the vehicle into the width of the vehicles, that will gives you the front projected area in meter square. So whereas V is the speed of the vehicle, so note down this, so this will be in terms of meter per second. Okay, so if the value of V is given in terms of kilometer per hour, convert it to the meter per second and then use it in this formula. And next one is the CA is nothing but the coefficient of air resistance. Okay, anyways, that will also given for you. The standards are there to take the value of air resistance. And once again, the G is the acceleration due to gravity. You can take that value as 9.81 meter per second square. So using this formula, you can determine what is the amount of air resistance that is caused, which will have resistance to the motion of the vehicle. The next one is the grade resistance. So grade resistance will come into picture especially when the vehicles travels at grades. So on the straight stretch of the road, there will not be any resistance because of this. Whenever your vehicle move in the upward direction or when the gradient changes, so there exists your grade resistance. So similarly, whenever the vehicle come down the hill, so grade resistance will be less, it will be decreased. So this comes to picture only when vehicles travel from straight stretch into the gradient. So gradients can be upward or the downward gradients. So upward gradients is always considered as positive, and if you travel on the downward gradient, so this will be the grade resistance will be negative. So now why does it occur? Why we have to consider the grade resistance? So whenever the vehicle move in a level stretch, it will be having a certain speed, maybe let us call as the design speed. Okay, so at the level stretch, your vehicles will be traveling at the design speed. So whenever the gradient changes, so maybe usually, especially in the upward gradient, positive gradients, so additional effort is required for you to maintain the same speed. That additional work that is required to maintain the same design speed will be equal to amount of work done to lift your vehicle to the desired inclination. Okay, so here this is this inclination which is given by the gradient. Hence, if the horizontal distance is unity, that is 1 meter, and what is the slope is 1%, I percentage, the rise will be equal to I divided by 100. So what is that additional force that is required to lift your vehicle is given by the formula Pi equals MIG divided by 100, where M is the mass of the vehicle, I is the gradient, that is in terms of percentage, and small g is the acceleration due to gravity, that can be taken as 9.81 meter per second square. The grade resistance value will become positive whenever the vehicle move in the upward gradient, and the grade resistance value will be taken considered as negative when the vehicles moves in the downward direction. So the next parameters which will cause the resistance to the motion of the vehicle is inertial force due to acceleration and deceleration. How it is important and where it comes into picture. So whenever you're traveling at a some design speed, so if you want to increase the speed of your vehicle, you need to accelerate your vehicle. So for that acceleration, additional work is to be done. Similarly, your vehicle is in stop. To bring it to the motion, you need to accelerate your vehicle. So there also to start your vehicles from the stopping condition to moving condition, you need to apply some pressure. Additional work need to be done. Similarly, if you want to bring your vehicle to stop, or you need to reduce your speed, you need to apply a brake, and additional work has to be done in the application of the brake to bring your vehicles to the stop. This additional force required, we call that as the inertial force. So which is denoted by letter Pj, and you can calculate that as the mass into acceleration, because that will depends upon your what is the total weight, what is the additional weight required will depend upon the what is the mass of your vehicle and what is the amount at which you are accelerating or decelerating your vehicle. So once again here Pj inertial forces will be plus or minus m into a. You will consider positive whenever the vehicle accelerate, and the sign will be negative the deceleration condition. Okay, so you need to substitute your acceleration and deceleration value should be in terms of meter per second square. So therefore total resistance to the motion PP will be summation of all the resistance: grade resistance, air resistance, resistance due to inertia, and also the resistance due to the gradient. So apart from that, we have one more loss, that is transmission losses. Losses in power occurs due to the mode of power transmission from the engine to the gear system, and or it can also be within the gear system itself. All the vehicles will have the system of gates, so which can be used to alter the speed of the vehicles with relative to the what is the speed of the engines we have. For example, whenever you want to start your vehicle, you require very high speed, but the speed of the vehicles will be very low. So another example, high engine power is required to climb the uphill, so but there also at the very relatively lower speed compared to the driving what is the engine power that is required for you to drive the vehicles in the level stretches. On the other hand, higher gear will be used when your vehicle will travel along the good surfaces with the less resistance, and you can also achieve a high speed. So the total effect of all these, the change of gear with respect to the speed, will consume about 10 to 15% of the total engine power. So that may be for the small vehicle, so that value can be as high as 25% in case of higher trucks which is carrying a greater vehicles at their lowest gear. So as I already mentioned you, all these resistance to the motions are considered to determine the what is the engine power required to maintain the desired speed. So now that what is that engine power required can be calculated using the formula power output. So PP into 0.377 into RWN divided by GTGA into RW. Okay, so here PP is nothing but the what is the total resistance sum of air resistance plus grade resistance plus rolling resistance plus resistance due to inertia forces considering the transmission losses. Okay, so here how you got 0.337. So here we have conversion from conversion of speed from meter per second to kilometer per hour, because all our speed value will be in terms of kilometers per hour. So RW is the factors which is related to the radius of tire. So that can be calculated as gamma into R naught, where gamma is the tire deformation factor, so which can be taken as value as 0.945 to 0.95. Value varies in between that. And n is the number of revolutions per minute. What is the number of rotation of your wheels per minute divided by gt into ga. So gt is the transmission gear loss and ga is the rear axle gear ratio. So determine, using this formula, calculate what is the power output. So we do have our numericals based upon calculating the what is the power performance of the vehicles, that we will discuss that in the further classes. Thank you. Having the knowledge of road user characteristics and vehicular characteristics, so let us move on to our next topic, that is traffic flow theory. Let us first understand what are all the components of traffic flow theory and what is the requirement of traffic flow theory. So with the help of traffic flow theories, we can actually study the movement of vehicular over the road network, and the parameters which are essentials to study are includes the speed, flow, and the concentration of the traffic. With the help of traffic flow theories, we can able to derive a mathematical relationship between the fundamental parameters, that is the speed, flow, and the concentration. So let us first define what is a speed, what is concentration, and what is flow. So let us define what is flow. Flow, we can also call it as the volume of traffic. So it is defined as the number of vehicle passing a specified point during a stated period of time. So what it is? So you take any particular point and we need a time, fixed time. So let us assume it as a 5 minutes. So in that particular point, how many number of vehicles will pass in a duration of 5 minutes? That will gives you the volume of traffic. So usually that is expressed in terms of vehicles per hour. So we will measure the number of vehicle passing a particular point in an hour. So how many number of vehicles can pass that particular point? So that you call it as the volume or flow. So usually it is expressed in terms of vehicles per hour. So it can be 100 vehicles per hour, 200 vehicles per hour, 300 vehicles per hour. Okay, so flow or the volumes, that will gives you the one and the same meaning. The next parameter is the concentration. Concentration, you can also call that as the density. So now what is the density? So as you already know, how many number of vehicles can be occupied in a particular place. Okay, so it is defined as number of vehicle present in a stated length of road at an instant. So I have a vehicle, let us take that this is my road stretch of 1 kilometer length. So now how many number of vehicles you can accommodate in 1 kilometer of road in unit time, in a fixed time, at an instant of time. So that will gives you the density. So for example, in a signalized intersection, so during the green time, for example, your green time is allotted for a 1 minute. Okay. So during that green time, how many number of vehicles will pass the intersection? That can be measured as a flow. That is the flow. So that their time interval is time interval fixed for green time. So your point is crossing the intersection. How many number of vehicles will cross the intersection during the green phase? That is one example for the flow. So next we have concentration. So we'll look what is concentration. Concentration can also be called as the density. So now density is nothing but what is the number of vehicles that are present in the defined length of the road at an instant. that you call it as the density. So example is, we can express that in terms of vehicles per kilometer. That is, take a 1 kilometer stretch of road. So within this 1 kilometer stretch of road, how many vehicles can be occupied? So that will measures the density of traffic. And the next parameter is the speed. The speed is nothing but the rate of movement of the vehicles or rate of movement of traffic. So usually it is expressed in terms of kilometer per hour. If at all meter per second is given, you can easily convert it to kmph by just multiplying the value divided by 3.6. Okay, so anyways, in with respect to the traffic, your vehicular movements will be measured in terms of kmph. So there are two ways of measuring the speed. The first is the measuring the speed with respect to the time. The second one is the measuring with respect to the space. So if you measure the speed in terms of time, we call that as the time mean speed, and when the speed is measured in terms of space, we call that as the space mean speed. So now how you will look into that, how to measure the speed in terms of time and space. The first one is the time mean speed. So before going to the definition, so I'll just give you an example how to measure the speed. So you just need to consider one reference point. Okay. So now here we need a time for the measurement of your speed. So let me take in a duration of 5 minutes. In a duration of 5 minutes, note down speed of all the vehicles passing this reference point. In a duration of 5 minutes, whatever the vehicle that passes the reference point, note down the speed of all the vehicles. So let the speed of first vehicle be V1, V2, V3 and V4. So continuous and for n number of how many number of vehicles that have crossed that particular point. So then take average of all the points that will measures the time mean speed. So you will have a reference point, you know the fixed duration, whatever the number of vehicles that passes the reference point, note down the speed of that particular vehicles, each and every vehicles. So average of all the vehicles will gives you the time mean speed. So that is, it is defined as the arithmetic mean of speed of the vehicles passing a point within a given interval of time. So mathematically you can express it as 1 by n summation of Vi. So that is nothing but V1 plus V2 plus V3 up to Vn divided by n, that is the number of vehicles. So next we have the measuring the speed with respect to the space. So space is nothing but the fixed length. Okay, here we have a fixed point, a reference point when you measure the time mean speed. So when you want to measure the speed of vehicles in terms of space, what we have to do is we need to consider a road stretch. We need to fix your road length of the road. So now measure what is the speed required for various vehicle to travel in this stretch. For example, I'll take this as a point A and point B. So let the vehicle passes from point A to the point B. So what is the speed that is required for your first vehicle to pass reference A to reference B? That will be V1. So similarly, for the second vehicle, what is the time required to pass point A and point B? That is V3. So now like that, note down for n number of vehicles. So for example, your sample size is 10. For set of 10 vehicles, what is the time required to pass from first reference point to the second reference point? Note down the speed. So then take the average of it. That will gives you the space mean speed of the vehicles. So next we have space headway and time headway. So space headway is nothing but the distance between the fronts of the successive vehicle. So here my vehicle, first vehicle is here, second vehicle is here. What is the distance between the front side of each vehicle? So that we will call it as the space headway. So next one we have time headway. So now what is time headway? So first is we have a reference point. Now what is the distance at which your first vehicle and the second vehicle will crosses the reference point? So there will be a time lag. Your both the vehicles will start at first reference point. So when it crosses the second reference point, there can be a difference. Okay, so now what is the difference in time between the two vehicles? So that we call it as the time headway. So space headway, we will measure it in terms of the space. The distance between the front of the successive vehicle is measured in terms of space. That we call it as the space headway. So time headway, it is to pass a particular point. What is the time required? The lag, the difference in interval between the passage of front of two vehicles, that we call it as the time headway. So these are some of the important terminology which is required for you to understand the traffic flow theory. As I've already told you, traffic flow theories will gives you the relationship between the speed v, flow which is represented by q, and density which can be represented as k. So the relationship between these three fundamentals can be understood by the traffic flow theories. So now the first fundamental diagram what we have is a relationship between the flow and the density. So what is flow? Flow is nothing but the number of vehicle passing a particular point is a flow. And the density, what is the number of vehicles that is occupied in the given length of the road. So we'll look into that, what is the relationship between those two. So the picture here will show you the relationship between the density and flow. So now as the number of vehicle increases, as the first initially there are 0 vehicles, so when the vehicles are 0, the density will also be 0. All the roads are designed to take some amount of traffic volume. For example, your vehicle is designed to take 1000 vehicles per hour. So up to this value, there will not be any delay. You can expect a free flow in the traffic. So if and when the number of vehicles increases this particular value of 1000 vehicles per hour, so your flow will start reducing. Okay, and because of the delay increases and your flow will start decreasing. So that is what shown here in the graph. So your flow will increase up to a maximum value. It will take a one maximum value. That is nothing but the what is the capacity of your road. Beyond the capacity of the road, when it is increased, the number of vehicles is further increased in the road, so the flow value will start reducing. That means to say that the delay started in that particular road, and it will reach a 0 value once again at a point called K jam. That is nothing but the jamming density. So it means to say that once again the flow value becomes 0, but number of the constant density of vehicles are high. There are two conditions when your flow is 0. The first value when there are no vehicles in the road. The secondly, it will again come to the 0 value when the vehicles are completely jammed. Okay, that you call it as the jamming density. So now the point at which your flow is maximum, that we call it as the capacity of the road. So here there will, up to this point, there will not be any disturbance to the movement of your vehicle. So you draw a curve to this, you draw a tangent to this curve. This will gives you the free mean speed. Mean speed. What is the speed your vehicles can achieve with in a traffic flow without finding any disturbance to the flow? That you call it as the free mean speed. So second relationship is between the speed and the flow. So figure here represent the relationship between the speed and the flow. So similar to the previous relationship, here also your initially it start from zero speed and the zero flow. Ideally there are no vehicles. So when the number of vehicle increases, the flow increases. Okay, so up to again once again here we have it will up to a q max, that is nothing but the up to a capacity of road. So your flow value increases and will the speed also increases. So once it reaches the capacity, road capacity is reached, beyond that any addition of vehicles, so your speed value will start decreasing. So that is nothing but it is approaching your jamming density. So you can correlate your density also with this. So when the capacity of road is reached, so the speed value will start reducing, and once again this value will become 0. So this particular point we call this is nothing, this is also we call as a jamming density. Jamming density. So your speed will also become 0 at this condition of the jamming density. So this figure will gives you the relationship between the speed and concentration. So here first is initially when there are zero vehicles, first you can achieve when the density is 0, you can have a maximum speed. As the number of density increases, your speed value will start reducing and it will comes to 0 at jamming density. I've already explained that in the previous diagram. With this, I will conclude traffic flow theories, and in the next sessions, we will discuss on urban transportation and planning. Thank you.